were very intrigued by the fact that you really needed this kinetic energy or this translational energy of the methane molecule to kind of slam into the nickel surface to get that deformation of the methane molecule. So we thought, well, if that's really what is going on, then maybe we could do the following experiment. Maybe we could just take a nickel surface and we can adsorb a methane molecule. So methane as a molecule sitting on the surface, kind of freezing it onto the surface. And then the idea was, well, if we just take a hammer to that surface, well, maybe we can hammer that molecule apart. In other words, if you take a hammer, you get that deformation, you should push that carbon in close enough to the nickel, you get that methane molecule to fall apart, the CH bond to cleave. Well, we can't actually take a macroscopic hammer, but we can take a microscopic hammer. We can take an argon atom, inert gas atom. We can speed it up. We can make it move really fast. And we can direct it onto this nickel surface, which has these frozen methane molecules on it, and maybe we can make them fall apart. And indeed that works. If you take that argon atom and bombard the methane molecules with that argon atom, indeed, what you find is that the kinetic energy of that argon atom is just as effective in making that methane molecule fall apart on that nickel catalyst as the translational energy of that methane molecule itself. This is also, this kind of collision-induced dissociation is also a process, once you think about it, that must be going on all the time under high pressure reaction conditions. Because, you know, in these catalytic reactions you have high pressures, and you always have some molecules that are kind of weakly bound to the surface, just kind of hanging around. And at the same time, you also have all of these collisions of the molecules that are making up that high pressure with that layer of adsorbed molecules on that surface. So these collisions are happening continually. And so not only what's important is the actual energy of the methane molecule coming into the surface, but also what's important are the collisions of these other energetic molecules hitting the methane molecule that is already adsorbed onto the surface. And if you are a chemical engineer who wants to model the system so that you can simulate changing various parameters, then in order to have an accurate model, you need to know both the fact that you have the kinetic energy of the molecule, that's important in affecting that dissociation, but you also need to know that there are all these other collisions happening in order to have an accurate description of the system. So we call this chemistry with a hammer. And in fact, that is very much what is going on.